Hey everyone, guess what? I think I got this technology thing to work for me, so we're gonna try this out. Welcome, this is Mrs. Harms. First of all, I just want to say I really miss you guys. This has been really hard for me, and I'm sure it's been difficult and just weird and challenging for you guys as well, but we'll get through it. So, we're gonna jump into these notes. Thank you to Mrs. Metler, who's been helping us out with the notes while I try to get technology stuff figured out. We're going to pick up where she left off in talking about rational functions. Right? Remember, rationals are things that can be written in fraction form, and when we see them on a graph, they create asymptotes. So remember, what is an asymptote? Do you guys remember that? An asymptote is a line on your graph, and it's the shape of your graph gets really close to it, but it never actually touches. Okay, so it's a line that the graph gets really close to, but never actually touches. That is an asymptote. All right, and we're going to review those and see them on graphs today. Now, asymptotes, they affect our domain and range. Now, real quickly, remember what your domain is? Domain, we typically write it like this. It is your farthest left, and then we would put a comma to your farthest right. If we have to jump over anything, if there's an asymptote in your graph, then we would have multiple parts to our domain. All right, but remember, domain is your farthest left to your farthest right, and your range is your lowest to your highest part of your graph. All right. So now there's two basic parent functions that we think of when we think of rational functions, and the first one would just be 1 over x. What shape does the graph 1 over x make? So I'm going to show a little example of this. 1 over x, that graph looks like this. Okay, you guys will notice on the graph 1 over x, our graph swerves, and so we never actually end up crossing or touching our x or y axis, which means we have two asymptotes. We would have to, our farthest left, our domain would be negative infinity, because it keeps going out towards negative infinity, and then as we come to the right, we never touch 0 on the x-axis. So that's an asymptote. So it'd be negative infinity to 0, and then we'd hop over 0 and go from 0 to positive infinity as we go on to the right. And then for our range, the lowest we go is negative infinity, and as we come up, again, we have to stop at 0, hop over it, and then keep going on up to positive infinity. The graph that 1 over x squared makes, 1 over x squared, makes a graph that looks like this. Oops, sorry. Okay, so this time we have 3 sections to our graph. So depending on what is in our denominator, depending on what our graph looks like, that's going to tell us what our asymptotes, where our asymptotes are at. All right, so remember, your horizontal asymptote, these are the values that the function cannot equal. All right, so in other words, these are the y values that cannot work in our function. They do not work in our function. All right? Horizontal asymptotes. Remember, horizontal is from left to right. Right? There we go. That's flat. All right? And then vertical asymptotes. Vertical are up and down. Okay? These are values that cannot be plugged into the function. Because if we plug them into the function, then we end up dividing by 0, which will give us an error on our calculator. So we cannot plug these into the function because we end up getting an error. These are the x values that do not work. All right? We set the denominator equal to 0 and solve for x to find our vertical asymptotes. And the reason we do that is because if we have a denominator that's equal to 0, then that means we'd get an error. This is because we can never divide by 0. Alright? So, again, this is just a reminder of what your vertical asymptote does to your domain and what your horizontal asymptote does to your range. Alright, here's how we graph a function, a rational function, and then identify the asymptotes and the domains and ranges. Alright, so here we have 1 over x plus 2 minus 3. This minus 3 is going to tell us our horizontal asymptote. So I'm going to put this right here. Our horizontal asymptote is going to be y equals -3. Because your horizontal asymptotes are the y values that don't work in our function. Alright, so I'm going to go ahead and put that on my graph. Y, here's my y-axis, and then -3 is 1, 2, 3 down. So I'm going to put a horizontal line that goes through -3. There's my horizontal asymptote. Alright, then my vertical asymptote are the x values that do not work, and to find that we set the denominator equal to 0 and solve for x. So here our denominator is x plus 2. If we set this equal to 0, I have to subtract 2 on both sides to get x all by itself. So that means we're going to get x equals -2. So there is our vertical asymptote. X equals -2. So I'm going to find my x-axis right here, find -2 on my x-axis, and now I'm going to draw a vertical line. Alright? Once we have our asymptotes, remember the shape of our graph is going to look like this right up here, because we only have 2 asymptotes. Alright, so the shape of my graph is going to look like this. So for our domain, what's the farthest left our graph can go? -infinity. Then, as we come back over to the right, is there any place where we stop or swerve? Right here at this orange line, which was our x equals -2. So we go to -2, and then we have to hop around that -2, and we start back up again. And after the -2, then we can keep on going to infinity. Alright, for our range, the lowest our graph goes, this arrow is pointing all the way down, nothing's stopping it, so the lowest our graph goes is -infinity. And as we come up, we have to swerve or stop at this green line, which was -3. Alright, then we hop over that -3 and we can keep going on up to positive infinity. Okay, one other example. Right here. Okay, now this time, do we have anything on the outside not touching the x's at all? No, there's nothing out here. So what number represents nothing? 0. Exactly right. So our horizontal asymptote is going to be y equals 0. So I'm going to go ahead and put that on my graph. Here's my y-axis, and 0 on my y-axis is right there. So I'm going to put a horizontal line at y equals 0. Okay, so for our vertical asymptote, this time we have two sets of parentheses. We have two things in our denominator. So we're going to have to set the denominator equal to 0 for both sets of these parentheses. So I've got x minus 2 equals 0, and I have x plus 1 equals 0. Alright, and we're solving for x for both of those, meaning we're going to have two vertical asymptotes. So I'm going to add 2 to both sides, and that's going to get me x equals 2. And then here I'm going to subtract 1 from both sides, and that's going to get me x equals -1. So we're going to have two vertical asymptotes, one at x equals 2, and x equals -1. So x equals 2. Here's our x-axis. Number 2 is right here, and I'm going to put a vertical line going through there. Alright, then our other one, x equals -1. Here's our x-axis. Here's -1, and I'm going to put a vertical line going through that. Now, since we have sectioned our coordinate plane into more pieces, this time our function is going to look like this one up here. Alright, so in class we kind of described it as a frowny face. So the general shape of our graph is going to look like this. Alright, now for our domain, what's the farthest left our graph can go? Yeah, farthest left, -infinity. So we're going to have -infinity, and then as we come to the right, the first place we stop is at this orange line, which is at -1. After we hop over -1, we start back up after -1, and we go and we stop at another orange line, which is at the number 2. So then I put a little U, because we got to pull around that positive 2. And then after we get around positive 2, we can keep on going to positive infinity. Alright, and then our range, the lowest our graph goes, we've got arrows pointing down to negative infinity. As we come up, we have to stop, and we never pass this green line, which is at 0. But if we hop over 0, then we can see that our graph goes up to positive infinity. Alright, so I want you guys to remember that whatever is in your denominator, that's going to tell you your vertical asymptote. And what you're doing is you're setting it equal to 0 and solving for that x. So essentially, you're just switching the sign. Alright, this was an x minus 2, so our vertical asymptote was x equals positive 2. Alright, your horizontal asymptote is whatever you're adding or subtracting at the very end. Alright, and that's exactly like you see it. So here, since this was a minus 3, that means we've got y equals minus 3. This didn't have anything at the end, so the number that represents nothing is 0. Alright, hopefully this was helpful, and if you have any questions, don't hesitate to reach out. I'll see you guys next time.